Okay, we can learn before we get into the, of course these are the also properties. We can learn speed, velocity, acceleration. Speed, velocity and acceleration. Speed equal to the ratio between the distance covered divided by time. Distance covered divided by time. The distance is measured in meters, so time is measured in seconds. So therefore units of speed equal to meters by second. Meters divided by seconds. Meters divided by seconds. So that meter per second. So you see that these the two things are derived from the fundamental quantities: length, time, length to time. You see that these are the fundamental quantities. So speed is the ratio between the distance covered divided by time. Okay na? So you take this for example one model. Suppose he covered 10 meters in 10 seconds. He covered 10 meters in 10 seconds. What is his speed? So therefore speed formula equal distance covered divided by time. So therefore 100 meters divided by 10 seconds. That is equal to, if you cancel this one, so 0 get cancelled, so that 10 divided 1, so therefore that is equal to 10 meter per second, which means what is the meaning of this 10 meters per second? In 1 second he is covered 10 meters. He is able to walk, or otherwise we can understand that in 1 second he is able to walk 10 meters. He is able to walk 10 meters. So that is his speed. In 1 second he is able to walk 10 meters. That is the speed. Of course, you can take another model. He covered 1200 meters in 60 seconds. For example, 60 seconds. So that is equal to 1200 divided by 60. So 0 cancelled. The 6 is cancelled in 120 20 times. 120 in 20 times. So therefore this is equal to 20 minutes by second. 20 minutes divided by 1 second. So this is cancelled, so 1 second. So therefore 20 minutes per second, which means that in 1 second he can able to walk 20 meters. He can able to walk 20 meters. In 1 second is he can able to walk 20 meters. That is his speed. That is his speed. Of course, these things can be expressed in another form. We know that meters can be converted into kilometers. So 1000 meters equal to we know that 1 kilometer. So therefore 1200 meters equal to 1.2 kilometer. 1200 divided by 1000, that gives the conversion into the kilometers. So therefore 1200 meters divided by 1000. You can division with 1000, you can get the kilometers. So therefore this one cancelled, 2 zeros. So therefore you can cancel this 0, 1.2. So therefore 1.2 kilometer per 1.2. So here 60 hours, minute. Okay, minute. So therefore 60 seconds equal to 1 minute. 60 seconds equal to 1 minute. How to convert the seconds into the minute? Whatever number of seconds are given, that is divided by 60, because 1 minute equal to 60 seconds. So therefore we can convert into that seconds into meters, seconds into minutes. So we know that 1 minute equal to 60 seconds. Given seconds divided by division with 60 seconds, we can convert into the minutes. Like that we can convert minutes into the hours. So whenever the situation is demanded, we can convert that. So this is the speed. That is the speed. Coming to velocity. Velocity is defined as a displacement divided by time. Displacement is measured in meters. So meters, time divided by time. So therefore meters divided by seconds in the same way. So that the velocity units equal meters per second. For example, you take the same example. 100 meters divided by 10 seconds. So that is equal to 100 divided by 10. So that we can get 10 meters per second. This is also velocity. You can take this one also you can take it as an example of velocity. Okay, that is the conversion. Okay, when the units are same, you can understand that then the both speed and velocity units are same. What is the difference between them? What is the difference between the speed and velocity? Speed is a scalar quantity, velocity is a vector quantity. Scalar quantity and vector quantity. Speed is scalar. Scalar quantity means scalar can gives only the magnitude. Scalar Vector gives the magnitude and direction. Magnitude and direction. Magnitude in the sense, this is the magnitude. This is the magnitude. Magnitude in the sense, in 1 second they can walk in 10 meters. 10 meters. That is the quantity. That is the quantity. In 1 second he can able to walk 10 meters. That is the quantity. But in which direction he is walking, that is not given by the scalar quantity. That is not given by the scalar quantity. But whereas coming to this velocity, this is the scalar quantity. Scalar quantity is the vector quantity. This is the vector quantity. Vector gives, scalar quantity gives only magnitude. Only magnitude, whereas a vector gives the magnitude and direction. Both are given in the vector quantity. So how to know that magnitude and direction? I can explain. You take one example. You take this one. For example, this is the line is there. This is the length. So the one person is started here. The person is reached this point. Let us say that is the 100 meters. He completed this 100 meters walking in 10 seconds. Time in 10 seconds. Okay. Coming to that speed, obviously distance covered in a time required to cover. What is the time that so from this problem he required in 10 seconds he covered 100 meters. So that we can find out the speed. Only the person, whatever the distance it covered, irrespective of the direction. For example, suppose that person is walking like this. So speed is you have to measure what is the length it is covered, or force in whatever directions he can walk. What is the total length to be measured during this covering this walking this length. What is the time is consumed. That is the speed. Coming to that velocity, displacement means initial position of the object and final position of the object. Displacement in the sense the object initially where is there, finally where is there. Between that distance, this is the displacement. That divided by what is the time covered this entire length. So time is same, 10 seconds. Okay, that is the difference between the speed and velocity. So the whatever directions, so whatever directions we can move, we can walk. Entire length is to be entire length covered to be taken, divided by what is the time is consumed to cover the distance. That ratio is nothing but speed. But the thing is, velocity equal to what is the final initial position of the object and final position of the object. That distance between that two positions, the distance is there. That distance divided by the entire this covered to reach this final position, initial position to final position, whatever time is required, that time. That is the difference between the speed and velocity. For example, in this case, this is covered from here to here. Speed in 10 seconds, 100 meters. But velocity, this is the initial position, this is the final position. This is the initial position and this is the final position. That's why we have to 100 and 10 seconds. Both in this case, the two examples are same. The covered distance from here to here, velocity, speed, velocity, position, initial position of the object, final position of the object. This is the initial position, this is the final position. Again, the same 100 meters. That's why we can get the same. Okay. Whereas we can understand another example, you can take that another example. For example, suppose this is the, you take this circle. Suppose you take this circle. This is the initially the person is started here. If you know this diameter of this circle, diameter of this circle, diameter of the circle is equal, let us say that okay 3 meters, 3 meters. Suppose the person started here, he is walking along this path, he reached here, you cover this walking, it takes, let us say that okay, so 6 seconds, 6 seconds. So the speed equal to, how to find out the speed? Speed equal to the ring, on this ring, this is the circle periphery equal to pi d, formula, pi equal to 22 by 7. Let us say that this takes 7 meters. 7 meters. So 22 by second. So it is also covered in 7 seconds. Let us say 7 seconds. So pi 22 by 7, d equal to 7. So therefore it doesn't have any units, it is a constant. So therefore 7 cancelled, this is the meters. So therefore 1, so that this is equal to 22 meters. This is the length of this circle in 7 seconds. So that therefore speed equal to 22 seconds, 22 meters divided by 7 seconds. So this is equal to, this is something 3.14 meter per second. Okay. The same thing, if you want to calculate the velocity, you see here, velocity here. What is the velocity definition of displacement? Displacement means initial position to final position of the object. This person is started here, again he coming to that same position. This is the initial position and final position. What is the distance between the initial and final position? 0. So therefore the distance, the displacement equal to 0 divided by, you need to calculate this perimeter. Just in velocity, initial position of the object to the final position of the object. Initial position and final position, walking along this path and reach this initial position. So that what is the displacement? 0 displacement. You are coming to the same position. So therefore displacement 0. Of course time equal to 7 seconds. So 0 by anything equal to 0. Velocity equal to 0. Velocity equal to 0. That we have to understand. Okay. Otherwise, suppose this person is started here and he reached this point. What is the velocity? So approximately this is the, let us assume half portion. This is equal to pi d by 2. Half circle equal to, distance equal to pi d by 2. So therefore 22 pi d calculated, okay, 2 equal to 11 meters. So velocity, this is equal to the time, let us say that this is equal to the complete this one 3.5 seconds. Let us say 3.5 seconds. So therefore this is equal to 11 divided by 3.5. This is equal to 0.57 meter per second. That is the velocity. So that we have to understand. So this is the basic difference between the speed and velocity. Speed is a scalar quantity, velocity is a vector quantity. In the vector quantity means vector, we can get the magnitude, and this is the magnitude, at the same time direction. Is the direction in the anti-clockwise direction, in this direction. Anti-clockwise direction. Whereas speed, direction is not required in the speed. Only what is the distance covered? The distance covered from initial position to final position. But whereas velocity displacement, what is the position of the initial position of the object and final position of the object between that distance, the distance between that initial position divided by what is the distance time required to reach from initial position to final position. So that is difference between the speed and velocity, that we have to understand very clearly. Okay, coming to another term, acceleration. Acceleration equal to change in velocity divided by time, so therefore units equal to velocity, we know that meter per second divided by time second. So therefore if you simplify this one, meter per second divided by second, so therefore this is the meter per second into 1 by second is equal to, so meter per second square. This is the units. So acceleration units equal to meter per second square, okay. In 1 second, what is the velocity accelerated? You see here, if you observe that the speed, velocity and acceleration, these are all derived fundamental quantities. This is the meters, distance, this is the time, this is the meters and time. That's why these are all derived quantities. These things are derived from that fundamental quantities. Okay, so that is the acceleration equal to change in velocity by time. You take that, for example, let us assume this is the 10 seconds. From here to here, 10 seconds. 1, 2, 3, 4, 6, 7, 8, 9, 10. During this 10 seconds, he is cycling 10 meter per second velocity. Let us assume. Next to 11th second, he accelerated velocity to 20 meter per second. Accelerated his velocity 20 meter per second in the 11th the 10 seconds completed. He raised his velocity to 20 meter per second. With 20 meters per second, he was cycling 20 seconds. Next 10 seconds. Then next 10 seconds. So therefore from here to here 20, next 10 seconds, 20 seconds. Next 20 seconds. So next 20 seconds. Let us assume next 20 seconds he is cycling with velocity raised on the 11th second. He raised this velocity 20 meters per second. With the 20 meters per second, he was cycling for 20 seconds. So therefore, what is the definition? Change in velocity. From change in velocity equal to final velocity minus initial velocity. That is equal to 20 meter per second minus 10 meter per second divided by time, change in time. So that is equal to 20 seconds minus 10 seconds. So therefore this is equal to 20 minus 10 meter per second divided by 20 minus 10 seconds. So therefore this is equal to 1 meter per, if you simplify this one like this, we can get 1 meter per second square. So every 1 second he is accelerating 1 meter per second velocity. This is the meaning of this one. Every 1 second he is accelerating 1 meter per second velocity. That is the meaning. So we can write this is the 1 meter per second into 1 by second. This is the time. So every 1 second he is accelerating 1 meter per second velocity. That is the meaning. We have to understand the acceleration. So of course, if you get any doubt, meter per second means why we are not substituted. Speed means scalar. Acceleration is a vector quantity. So that's why we have to take the change in velocity divided by change in time. So like this we have to calculate the acceleration. That is meaning. Final meaning equal to, in 1 second, how many meter per second is accelerating? Velocity. That is the meaning. So in this case, every 1 second is accelerating 1 meter per second. Every 1 second accelerating 1 meter per second. That is the meaning. Acceleration. Okay. Like this we can do different varieties of problems in acceleration. If you understand this one, you can do any type of problem. You can understand any type of problem. Okay. Next, coming to that, acceleration due to gravity. Acceleration due to gravity. This is also same, the same change in velocity divided by change in time. Same, but thing is that the units also same. This is the velocity meter per second divided by second. This is also meter per second square. But thing is, we have to understand here acceleration due to gravity. So we know that Earth has a magnet, so that if you throw any object into the height, so obviously it is falling down. It is a falling down, which reached at a certain point. Next, it is falling down. During that falling down, you take this the time like this: 1 second, 1 second, 1 second. This is 1 second, 2 seconds, 3 seconds. Let us assume this is the ground reached. At this point, of course, it is 0. It is 0 from we reach to during this. Of course, we reach to, let us say that this is the 9.81 meter per second velocity. It attains 9.81 meter per second velocity. It travel in 1 second 9.81 meter per second velocity. Next, we reach to that second. The velocity is doubled, 19.62 meter per second. Next, 29.43 meter per second. 29%. You see, understand here. In the first second, its velocity 9.81. Next, it reached to second, the velocity is raised to 19.62 meter per second. Next, it reached to third second, this velocity reached to 29.43 meter per second. If you understand that, if you see that every second, the difference is 9.81 meter per second. 19.62 minus 9.81, you get 9.81. 29.43 minus 19.62, you can get 9.81 meter per second. So 2 to 1 second, 3 to 1 second. So every 1 second, the velocity is increasing 9.81. That's why the change in velocity equal to 9.81 for every 1 second. This is the meter per second. So therefore, acceleration due to gravity equal to 9.81 meter per second square. If you simplify that, we know that how to simplify that. That is the meaning. So every 1 second it is accelerating 9.81 meter per second velocity. 9.81 every 1 second. The velocity is increasing, rising 9.81 meter per second. That is the acceleration due to gravity. This value is constant. That was found out long back by the scientists. So that is the acceleration due to gravity 9.81. So thing is that acceleration is a general term that can applicable for anything. A vehicle going, you are walking, a vehicle, bike, train, aeroplane, anything. That is the acceleration. That is the term, general term. Whereas coming to that acceleration due to gravity, it is related to the earth. That is the acceleration due to gravity capacity. So that if you throw it any object, that object is falling with velocity of 9.81 meter per second. every second is increasing that it is reached to the ground. This is the meaning of the acceleration due to gravity and acceleration due to gravity and acceleration. Acceleration is changing, acceleration due to gravity is a constant 9.8 meter per second. It is changing depending on the velocity. If you are increasing when you are riding the bike or cycle or whatever it may be, we cannot go for the same velocity. Depending on the need, we can go for the, sometimes we can go for the slow. If you go into the town, depending on the traffic, we have to go for the velocity is rising or decreasing or increasing, or suppose you are increasing more, or suppose velocity is decreased, that is called retardation. Okay, so increasing, so that this is the acceleration, this is the acceleration due to gravity. So that is the difference between the two things you have to understand.